Yo, what's up friends? Welcome back to Angel and Tech. Today we're going to be doing a machine learning project. We're going to be doing stock price prediction. It's going to be a little bit of a lengthy video, so definitely feel free to skip ahead. I will be doing the code implementation at the end of the video, and I will be talking about what we're going to be implementing and why we're going to be doing it. So just stay tuned for that. Hit the subscribe button, turn on the notification buttons to watch some more awesome videos coming in the future. If you want to take a look at the future videos, go ahead and click the link in the description. But yeah, let's have fun and start coding. Cool. So as I said, today we're going to be doing a stock price prediction using Python. Our goals is to use the Yahoo Finance. We're going to be using the library, not the. It's connected to the API. We're going to learn what data we are using. We're going to clean, transform, and gather the appropriate data, prepare the data for modeling, and then create our machine learning classifier, and lastly, get our predicted results. So getting started, these are the libraries we're going to use: Pandas, NumPy, Matplotlib, yfinance, which is the Yahoo Finance, and sklearn, which contains our machine learning submodules to create our machine learning algorithm. So for those of you that don't know, Matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python. I didn't really use this or implemented it in this video, but you can take a look in the notebook that is uploaded into GitHub, and there will be some visualizations. I will also link this side project that I did based off stock price predictions that uses this library as well. And then yfinance, it's an open source library developed by Ran Arosi. So it uses all the financial data available on Yahoo Finance. And then, like I said, sklearn is the machine learning library for Python, and we're going to be using SVM, a support vector machine, and we're going to be using these metrics, particularly precision score, and then model selection to be able to train, test, split, and then grid search CV to be able to test different parameters and make sure we get the best machine learning model available to us. But yeah, those are the libraries we're going to use, and we can get started by just importing the appropriate libraries. And like I said, I like to put in a try and except clause only because if a library doesn't work, we want to see why it didn't work. So we run that. Awesome. So don't worry about this error. This is on my end. I have to update my Anaconda version, so you can just run it again and it'll go away. But now, yeah, let's get started, and I'll tell you what functions we're going to implement and why we're implementing them as to my thought process. Of course, you can do this however you see fit. You don't have to follow this structure, but this is how I did it and why I did it. Awesome. So the functions that we're going to implement is the first one we're going to do is get our ticker symbol data from Yahoo Finance. So before we start with any predictions, we have to get the data for the stock of our choice. So make sure you know what ticker symbol it is for the stock that you want to choose. And then we're going to pass in the start date and end date. So it could go as back as to 1960, I believe. If you don't want to go that far out, oh yeah, right here, 1950. If you don't want to go that far out, that's fine. And then you're also going to pass in how many days out you want to predict. So you could predict tomorrow's and the next days, and so on and so forth. So we'll pass in that value as well. And quick notes, like I said, some of the data can go back as far as 1950 if it's available. And the date format, you must pass in a string value in year, month, and day. And then we're going to do some simple data analysis, nothing crazy, because we're not doing any exploratory data analysis for this project. We're just going to be doing predictive values. So we can call head just to view the top 5 rows of data. We can call describe so we can see more about the data, and then info just so we can see the type of data we're working with, the data type specifically. And then we're going to work on adjusting our data. Since we are doing a predictive analysis, there are a couple things that we want to do. We want to make sure that we only have a data frame that only holds the adjusted values, and then we're going to create a variable to store the number of days to predict, which is what you're passing in, your forecasted days. And then we're going to create a different column that will hold the stock prediction, and that's going to be our target variable. And then we're going to do some data pre-processing. So we're going to create an independent data set, dependent data set that is our target data. And then we're going to use train and test split to split up our data. And then we're going to pass that data into our model. And then for create classifier, this is where it gets more intuitive. We're going to be using support vector machine models. For the kernel, we're going to be using RBF. Our C value is going to range between these ones, and then our gamma value is going to range between these. Now, I'm not going to go into specifics for what each of these mean. If you do have any questions, just send me a DM through Twitter or put it down in the comments if you want an explanation. I can also link some good resources for the explanation of these things in the notebook that you can check out on GitHub. And then after we have that, we're going to pass in the data using .fit, where we train the vector for the number of samples, and then we're going to be using a regression, so SVM regression model. And then from there we can just get our predictions using .predict, and we should be good. So those are the functions that we're going to implement. And like I said, there's definitely different ways to do this. This is just how I did it and how I've done it in my other side project. But yeah, let's get started and start coding. Alrighty, so now we're going to be implementing our functions. So our initializer is already here. We're passing in the ticker symbol, our start date, end date, and our forecast days. So ticker symbol is your stock of choice. Start date is the start date of your choice. End date, you can go as previous as the day when it closed, so yesterday, if it's not the weekend. You could also include the weekend. It'll take it into account. Or you could do a specific range between, I don't know, January 1st and January 31st of a certain year. And then forecast days, this is up to you. You can predict the days between now and then tomorrow, or from now to 100 days. So it's really up to you. So the first thing we're going to do, we're going to pass in the data. We're going to not pass in the data. We want to get the data from Yahoo Finance. So the cool thing is that this can be done like this. So now that we passed in, we imported this library, yfinance, as YF. We gave it an alias of YF. It has a sub function called download. So this takes in a stock name. So right here, self.stock, it takes in the start date, end date, and then the progress equals false. It just means whether or not you want it to be progressive. You could turn it to true or false, doesn't really matter. And then we could run this, and we should be able to see our data now. I'll show this at the end, but right now we're testing these two symbols, Amazon and Apple, with these start dates and forecast days of 2. But yeah, let's look at the first function and see what it returns. Func, sorry. Right here. So that's awesome. It did read in what we passed, and now what we got back is a date starting from 0104, and the reason is maybe because 0101 was a weekend. I'm not entirely sure. But yeah, it tells us the open, the high, the low, the close, and the adjusted close. It also tells us the volume, but we're not going to be working with volume specifically. We are going to be working primarily with adjusted close, as to that's how it ended on that day. Cool. So that's how you get the data from Yahoo Finance. The next thing, like I said, def head, def describe, and def info. These are just optional, so you can look at the data a little bit better. So we can just do return and then self.get data.head. So what this is saying is we're gonna, since this is returning, it's returning a data frame. So all we got to do is just call .head, and we should be able to see this in a better format. So we can do .1. Oh, none. Oh, that's because we didn't return it. It's printing none. That is very odd. Shouldn't be doing that. Let me see. Oh, there we go. I don't know why it was printing none, but yeah, it just formats it a little bit better, and we're able to read it straightly across between rows. And then same thing with this one, we just do return self.get data.describe, and then we'll do the same thing for df info, return self.get data.info. Then we can take a look at that. So we'll run that again. So now we want to do describe. So that's it. Prints out, it tells us our data columns and tells us our data type and if there's any non-null values in here, which is really cool. And then so this right here, this is our info. This is this portion right here. And then the df_describe does this. So it just describes what we're looking at, and yeah, that's pretty much it for those two. Like I said, these are very optional because we're not doing any exploratory data analysis on this. We're just going straight into machine learning to get predictions. Obviously in a bigger project, you do want to do some exploratory data analysis and see any trends that you can also look at and take into account when you're doing machine learning. But yeah, the next part is adjusting our data. So like I said, in the functions that we're implementing, we want to adjust our data to make sure that we only have adjust close in our data frame, and then we're going to create different we're going to adjust the data frame to store the number of days out of what we want. So right here, we're creating a copy of the original data frame, and then within that copy that we have, we're just going to want the adjusted close column and all its values. And then we're going to be adding another column called stock prediction, and we're going to be adding it to the right of adjust close. And along with that, we're also going to be shifting the rows, the number of days out. So if you're passing in 2, there should be 2 rows, and we can take a look at that as well. So we want to make sure we get this one. So that would be number 4. Right here, exactly. So we adjusted our data set to make sure, but we adjusted our data set so it can contain 2 values that will be our predictions once we get into machine learning. Our next step is to do some data pre-processing. This is where we split the data into X data, Y data, and we have our training values and testing values. And we do this by doing X data equal to numpy.array. And we're going to be dropping the column stock prediction because we don't want that in our independent data set. We want that in our dependent set, which is right here. And then we're also going to make sure that we take into account the number of days shifted. And then we're going to pass in those values into train test split, where we have 80% testing and 80% training, 20% testing. So make sure we understand that. And then we're going to return those values as X train, X test, Y train, and Y test, where we pass that in to create our classifier. Cool. Now, to create our classifier, we're going to create a dictionary called param grid. This holds our C values, our gamma values, and our kernel. Like I said, I'm not going to go deep into what each of these mean. If you do need an explanation, just at me at Twitter, or put it down in the comments and be like, Angel, what does this mean? And I'll be happy to explain it. So we're going to pass this param into grid search v, which takes in the classifier we want and any parameters that we see. So, and then this refit equals true and verbose equals 3. When I was testing this, what this does is it goes back again and keeps testing and testing until it finds a good fit. You can use this, or you don't have to. It's really up to you. But just for the sake of this video, I'm not going to be using it, only because it does take some time. And I do recommend you use it so you can see what it does and try it out on your own. But we pass that into grid search v, these 2 parameters. And then our final classifier, we're going to fit our data. So right here, when I say self.data preprocess, and we're getting the first element, which is this, and then self.data preprocess, and then this. We're testing it on those two things, and then we're going to return our find null classifier. And then to get our predictions, we're going to set this into a NumPy array where we drop the stock prediction, and we make sure that we shift back to the number of forecasted days, and then our predictions are going to predict this NumPy array. It's going to take into account what this has and use it to predict our new predictions. So we can run that, run this. We don't need to run this anymore. We can just print this out, and it will take a while only because it's going to go through all these parameters. It's going to test 0.1, 0.1, 0.1, 0.01, 0.1, 0.001, 0.1, 0. And you get the point. It's going to test all of them against each other, see which one generates the best predictions. Cool. So now we see that 47 gives us the two predictions for the next 2 days. Now, is this necessarily right? It's hard to tell, because like I said, this only goes up to from this day to this day. If we look at the Amazon stock price, right now it's 133.76. So clearly it is not correct. We don't see it. It's not right. And what the reason I'm thinking is because, like I said, we're not using the entire data set, and we're only using 2 days, and then we're not refitting for it to fit nicely. So those are some things that you can change. But yeah, that's it for that project. It's very straightforward. You could do this on your own and test out different test sizes. You can break up the X data differently if you wish. You can also adjust data completely different, really up to you. Maybe you don't even have to use adjust close. You can use something different. Like I said, do some exploratory data and look at that. But I do recommend always using the as back as you can for the start date and as close as you can for the end date, just to test the waters. But if we take a look at one of the projects that I did on GitHub, you'll be able to go, you could go to I am Angel SH, and then I should have it under Streamlit stock prices. And if you click on this, it's a web application that I created called Stock Price Prediction. It tells you how to use the app. Please read. This is not for you to take advice from me on the stock prices. But if you type in your ticker symbol and then you do 1 day out, you get a graph of this awesome stock. You can make it bigger, and you can look at the trend between prices when it started up to now. You can drag it, you can zoom in and take a look, which is really cool. But what I want to show you is the prediction. We have 138.15 for tomorrow. And if we look at the current stock price, let's refresh, it's 133.46. Now, is this necessarily 100%? I would say no, but you can, like I said, hypertune it, create different parameters to make sure you get as close as you can. I believe when I did this, my machine learning model had a accuracy score of 87 and a precision score of 88, so it did pretty well. But you can increase the day, and it'll load right here, and see how it goes up and down, and you can keep doing this for as many days as you want. You can also change it. Let's do Apple, and the graph changes as well as the stock prices. We can take a look at the Apple stock price. We see it's 167 and currently it's going down, so it's really up to you. It's relatively close, but like I said, this is not for professional advice. This is just for fun, and this is just one thing that you can do by understanding how to get the stock data, do some stock predictions. But yeah, that's it for this video. I hope you did learn something. You had some fun coding. And like I said, I didn't go too deep into the machine learning aspects, only because this isn't necessarily a get started with machine learning. But if you do want an explanation of what each of these individual concepts are doing, just like I said, at me on Twitter at IamAngelSH, or write something down in the comments and I'll be glad to help. But yeah, that's it for this one. Follow me on Twitter, subscribe, hit the like button, turn on those notification buttons, and I'll see you in the next one. Have fun.